Hello friends, so let's try to solve this particular equation, this particular problem. This is from TIFR and question number is A5. So what is in this particular problem? Object is falling in the air. In the addition of gravity, there is some resistance force which is proportional to V and the proportionality constant is B, where V is the speed and B is constant. It is given. If the object dropped from rest, V is equal to 0 at t is equal to 0, the distance traveled by the object at the time t is equal to m by b is what? So we have to go for that particular distance at this particular time. So this is a very simple question, straightforward. Only thing is that how you are going to solve the first order differential equation. So let us try to do this problem step by step. So what is my equation of motion? My equation of motion is basically m dv upon dt is equal to mg minus bv. So this is my equation of motion for v, and this is dv upon dt. We can write g minus b by mv. And what is going to happen? So we can put dv upon g minus b by m. V is equal to dt, and we have to go for this particular integration. So how you will go for integration? This is very simple one. So you can put g minus bv by m is equal to y. So you have dv is equal to minus m by b dy. So what is this particular value? Minus m by b dy upon y is equal to dt, and minus m by b ln g minus b by mv is equal to t plus some initial constant c. So what we have to do? We have to just find this particular constant. So it is given at t is equal to 0, v is equal to 0. So c is equal to minus mb ln g. So what will happen? We can rewrite this particular equation. And once we will rewrite this particular equation, then we have v is equal to mg by b, and what you have 1 minus e to the power minus bt upon m. So this is a very nice one. You can see that at t tends to infinity, the velocity is constant and it is just going to be saturated. So at a t, very large t, the velocity is almost constant. So it's a wonderful. So let's go for next one. So we have dx upon dt is equal to mg by b 1 minus e to the power bt upon m. And once we are going for integration, then x is equal to basically mg b into t, and we have minus sign mg b upon minus b upon m e to the power minus bt upon m plus some constant c. So what will happen at t is equal to 0, x is 0 because it is, we have reference at t is equal to 0 at the origin. So what will happen? We have c is equal to this minus sign, this will be 0, this will be 1. So we have basically m square g upon b square. So this is your value of c. So what is your x? X is equal to mg by b into t minus mg, and you have m square g upon b square, minus plus is there, and you have this value is equal to minus plus, so this value is negative. So this value is minus m square g upon b square. So what we have to do, and here is you have e to the power minus bt upon m is also there. So what we have to do? We have to put t is equal to b by m. So when we will put t is equal to b by m, then x is equal to mg by b and b by m. Sorry, m by b is actually. So this will be m by b, and plus we have m square g upon b square e to the power minus 1 minus m square g upon b square. So this and this is cancel out, and what you will get? You will get x is equal to m square g upon b square 1 upon E. So this will be your answer. So it's a very simply you can get the option number A is your correct answer. So students, this type of question is very interesting. The thing is that you can again go for the next level. What will be profile of B versus T? What will be profile of X versus T? And these all things very fortunately we have discussed in our class of the mechanics. So you can just go for all this topic from our lectures and you will find exactly same question, same method we are just following in our class. Thank you.